Hello everyone, welcome back to the YouTube channel Devotion of Knowledge. So today we are back again with another coding problem named Palindromic Path. As you can see on the screen, it is a Codeforces problem and it is a 1500 rated problem and it's having a tag of greedy and math. So let us first understand the question and then we'll move towards the intuition and the coding part of the problem. So the question states that you are given a matrix with n rows and m columns. n rows or m columns का एक matrix दिया है. Each number is either 0 or 1. Okay. A chip is initially in the cell 1, 1 and it will be moved to the cell n, m. तो स्टार्टिंग के वर्टेक्स पे हम यहाँ पे खड़े होंगे पहले पॉइंट पे और हमें n प्लस m मतलब कि n, m मतलब कि इस वर्टेक्स पे जाना है. और हम किस तरह जा सकते हैं? During each move, it can either move to the next cell in the current row. If we are standing in a current row, then we can only move to the next element in that row, otherwise we can move to the same element in a same column. Means either हम राइट जा सकते हैं या तो हम नीचे आ सकते हैं. यही दो ही मूवमेंट पॉसिबल है. Consider each path of a chip from 1, 1 to n, m. A path is palindromic if the number of first cell is equal. Okay, palindrome तुमको सबको पता है, आगे से रीड करेंगे पीछे से रीड करेंगे, it will be same. So your goal is to change the values in minimum number of cells so that every path is palindromic. अरे भाई क्या बोल दिया? We have to make changes in the grid which is given to us such that each and every path possible from the source node to n, m means 1, 1 to n, m. Each and every possible path between these two vertices should be palindromic in nature. Okay, let us take the test case which is given here 3, 7. Okay. Okay, recording is still going on. Just a second. Okay. So this is the grid given to us. Initially we are standing on this point and in each move I can either go into this one or into this one. If I go to this one, again there are two possibilities. I can go to the next element in the same row or I can go to the next element in the same column. So either standing on this one, either you can go on this side or you can go on this side. These are the only possibilities that we are allowed to do or to move in such a manner. So initially I will be standing here. So let us say this is a level 0. Okay, so if I go to this one or to this one, so I can say this two positions are at distance 1 from the starting position. So can I tell it as a level 1? Okay, this is the level 1. Now if I am standing at this node, I can either go to this one or this one. So can I say that this position is at distance 2 from the starting position? Okay, I can say, okay, these two are at distance 1. This will be at distance 2. Similarly, this is also at distance 2 because I can go from here to here or from here to here. This will be also at a distance of 2. Okay, this will be at distance 3 because it is at level 3 from the starting node. Second one, third one and the third one. Okay, so this is similarly at level 3. This one is also level 3. This will be level 4. This will be also level 4. Level 4. Level 5. 5. 5. Level 6. Level 6. This will be at level 6. This is at level 7. This is also level 7 and this is at level 8. So number of rows given to us are 3 and number of columns given to us are 7. And the last level which is possible is 8. So I think it is making some sense to you guys. So okay, so how many levels are possible if we consider zero based indexing? It will be n plus m minus 2. These are total levels possible. Just keep this small thing in mind. Now let us come towards the main logic. If I am taking this path, so I am standing currently here. So if I consider this path only, I will go always on the right hand side of the part, or on the right index only. So here I am standing. So what are the possible paths from which I would have come to this index? One is this one, and one is this one, because these two are at level 1 from the end index. So if I am just taking this path, so both these values should be equal to this value. Let me repeat. If I consider this path only, I am not going on this side. No, I am not going. I am just going from this index to this index. So these two values present here and here, they should be equal to this value, because we are supposed to tell that all the possible paths should be palindromic in nature. So index which is at distance 1 from starting node, similarly the index which is at distance 1 or level 1 from the ending node, they should be equal. Okay, similarly if I take this path only, if I go from this to this only, then these two indexes should be equal to this index, because again the path should be palindromic. Similarly, if we consider level 2, these are level 2. So if I consider this element only, so all the elements present on level 2, which are this, this and this, they, all these elements should be equal to this element. But if we consider only one element, but on level 2 also these are the elements present, so what should be done in ideal case? Okay, let us make an array in which this is level 0, 1, 2, 3, 4, 5, 6, 7 and 8. Level 0, 1, 2, 3, 4, 5, 6, 7 and 8. These are the total levels possible. Let us just count how many ones are on each level. So on level 0, 1 is there. On level 2, this is level 2. Okay, so this is level 1. Number of ones on level 1, 0. Number of ones on level 2, this and this. 2. Similarly, number of ones on level 3, 2. Number of ones on level 4, 2. Number of ones on level 5, again 2. Number of ones on level 6 are also 2. Number of ones on level 7, 0. And number of ones on level 8, which is 1. So let me tell you, if I consider this element, then all the elements present at distance 2 should be equal to this element. But here we are having 3 elements which are at distance of 2 from the starting node. So can I say that to make sure that all the paths are palindromic, all the elements present on same level should be equal to all the elements present on the same level from the end of the grid? Let me repeat again. All the elements present on level 2 on this side, all the elements should be equal to elements present on this side of level 2 from the end vertex. And then only we can say that all the paths which are possible will be, we can say, palindromic in nature. Okay, so how to do it? Here two ones are there, and this is level 0, 2, level 2, 1, 0 is there. On level 3, similarly 1, 0 is there. Level 4, 1, 0 is there. Level 5, 1, 0 is there. Level 6, 1, 0 is there. Level 7, 2 zeros are there. And on level 8, okay. On level 1, 2 zeros are there. Okay. So we should make sure that all the elements are equal. So how to do it? How many changes we have to make? For example, on level X, say on this side, and level X from end, 2 zeros are there and 1 ones are there, and 3 zeros are there and 0 ones are there. Then what should be done in this case? Should I convert this 1 to 0, or should I convert this 2 zeros to 1? Okay, these are zeros and these are ones. So we are supposed to answer the minimum number of cells. So what is the minimum number of cells? I should be converting this 1 to 0. So I will be require just only one operation. So can I say that on each and every level I will be taking the minimum of all the zeros and all the ones present on that particular level from starting and ending of the grid. Let me repeat again. I will be just taking a minimum of zeros and ones from both the sides of the grid at particular level. Then and then only I will be considering or getting minimum answer possible. Okay, now question is solved. This was the main logic that we are supposed to find. So let us see here. Okay, where is the cursor? Here it is. So this is level. Okay, so at this level and at this level, elements should be equal. Number of ones 1, number of zeros will be 0. Okay, so there is not any requirement because all the elements are equal. Similarly on level 2, two zeros are there and one zeros are there, so no, it's not possible. So we have to just increment, or we can say plus our answer by 1 here, because this is 0 0 0 0. Okay, here nothing will be required because all the elements are equal. Just let me clear this grid, it is very messy, looking very messy. Okay, now let us come on level number 2. 1, this will be this is level 2, 1 2 and 2. Okay, this is level 2 and 1 2 2 2. Okay, these are the elements 101 and 101, but here we can see all the elements are not equal. So we have to make some changes so that they are equal. Then what are the elements that we will increment? We can see we will make this zeros to 1. So we will be changing this zeros to 1 and our answer will be 2 right now. Okay, let us move to the next level. Similarly 101 and 101. What are the okay, similarly same problem is here. Then we will again we have to make this two zeros to 1. Okay, okay, now we are coming on this level 1 0 and 1 and 0 1 1 1 1. What changes we have to make here? Can anyone guess? We have to just change this value by 1. So total number of operations required is 5. Okay, there is some error. Okay, we made one mistake. When we are on this level, which is the middle level, is there any need to make any changes? I don't think so, because it's a middle level and all the path possible will be going through this one, so it won't create any problem because it's the middle index and it is not contradicting with any another level to create any clash. So there is no need for us to change that. So total possible answer or total number of cells that we have to change is 4. So I think the approach towards the question is clear to you guys. Let us directly move towards the coding part. So here is the code that we will be understanding. So right now we are taking the input, as you can see here, taking the grid as an input, and as I told you, we have to check how many zeros and ones are there on each level. So as I told you, n comma m, so total is 3 comma 7, then 8 levels were there total. So we have to take the arrays of size n plus m minus 1. So here we have taken this much size of arrays and we will be just counting that how many zeros are there on each level and ones are there on each level. I plus j, because we are supposed to find a level, because 0 comma 1 and 1 comma 0, these two indexes are having at same level, so I plus j will be 1 and I plus j will be 1 on this side as well. So We are just checking that how many ones are present on each level and how many zeros are present on each level. Okay. Now let us go on this side. This is of no use. I was at the time writing of code, I was just thinking of some other logic, that's why. Okay, now let us erase these things. Okay, now here, this is the main logical part. N plus m minus 1 by 2. So as total of 8 levels are possible. So what are the combinations that we are going to take? 0, 8, 1, 7, 2, 6, 3, 4 and 5, 3. But there is no need to take this combination because let's take the array so that it will get more clear. 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7 and 8. Okay. So one is this one, another is this one, 0, 8, 1, 7, 2, 6, 3, 5 and 4, 4. But is there any need to consider this level? I don't think so. So that's why n plus m minus 1 by 2. So total of 10 minus 1, 9 by 2 equal to 4. So we will be just considering levels 0 to 3 because here as you can see we are keeping less than. So it will be just turning to 0 to 3 levels only. Okay. So if I am standing on this level 0, then what will be the corresponding level that I will be checking on the opposite side? It will be 8. How can we get this 8? It is n plus m minus 2 minus I. 0, I. If I am standing on level 1, then opposite level that I will be checking is level 7. So what is 7? N plus m minus 2 minus I, which is 10 minus 2 minus 1, which is equal to 7. Similarly, 2 comma 6, n plus m minus 2, 8 minus 2 equal to 6. So this is the formula to check that how many elements are present on the contradict or the clashing level on the another side. We will be getting all the summation of zeros and ones of the corresponding levels and we will be just incrementing our answer by whatever the minimum value is there on that particular index of 0 and 1. So I hope this logic is clear. This was the main crux or the main logic behind the problem. And the main logic is to compare all the levels which are contradicting, level 1 on this side, level 1 on this side, level 2 on this side and level 2 on this side. So this was the main part of the logic of the problem that we were supposed to learn, and that's it. And also you can say it is a 1500 rated problem, which is of quite good rating, I would say, because it is not a straightforward problem. It requires some quite good observational skills to make sure that how to approach towards such kind of problem and how to break the problem into subsequent parts. So I think that's it from my side for this particular problem. Please give this problem a try. I will be attaching a link of this problem in the description part, and we will be meeting in the next video very soon. Till then, keep learning, keep hard working. Thank you very much.